Hello YouTubers and fellow hams. On the bench this morning I've got an Icom IC-V8000 2-meter mobile. This is a high power mobile. It's 75 watts on full power, which the whole top half of the thing is a heatsink. All this back here is a heatsink from the front all the way back. Massive heatsink fan on the back because 75 watts, that's a lot of power. Anyway, got it hooked up. The receive is working fine. I've already been picking up a few things with it. But when I go to transmit, nothing. It will not go into transmit. And I have got that problem pretty much figured out just at a glance. And I'm going to show you why it's not transmitting. This is the problem. RJ45 connectors. Now I don't know why Icom ever thought it would be a good idea to use these for microphone cables. Let me reposition the camera and set up for a close-up here, and I'll show you what is probably going on. In fact, yeah, I can see it from here. So I'll show you what's going on with these connectors. So the RJ45 connector is a pretty common connector type for, say, Ethernet networking. And the way that it's built, yeah, this is the good end. Hopefully you can see this. But right here is a little crimp strain relief that crimps down into the cable to relieve strain. And then the wires go down these channels here, and these little gold contacts have little tiny blades that pierce into the wire to make electrical contact when this is crimped down. And then on the back of the connector you've got these 8 gold-plated contacts. Each one connects into a wire that is pushed in there and then crimped down, and these blades bite in. It's a great connector for infrastructure and networking because it's quick to put on. You just line your wires up, push them in there, and you crimp this down and you're done. So it's a very quick connector. But in the instance of like a microphone cable, where you've got a lot of wiggling and pulling on that, it's a really bad idea. And you can see on this end of the connector of the cable, hopefully you can see this, get that angle just right, the sheath is back behind that strain relief. It's been pulled out of that strain relief. So now there's tension on these wires, and that causes a break and a loss of connection up here. Let's go up to the main computer and I'll show you that graphically, and you can see exactly why this is a problem when you've got a cable that gets wiggled and moved around and pulled like a microphone cable. Well, pardon my crude illustration, but I couldn't find a good profile of an RJ45 connector on the web, so I just sort of threw this together. So this is the profile of that connector, and your cable comes in here, and right there is the crimp, a little triangle piece of plastic that the crimp tool pushes into the insulation of the cable to lock it into the connector. And that's supposed to be a strain relief to take strain off from the cable moving around. The wires from the cable come in through a sloped channel and run along the bottom edge of the connector, and those are separated out into 8 little tubes that the wires stick into. And then you've got 8 gold-plated blades up here mounted into these things here, mounted into slots on the connector. And when your crimp tool comes in, it pushes this blade down. And when it pushes this blade down, the sharp points of the blade here will bite into the wires down here in the channel and pierce through the insulation and make contact with the copper. That's the problem with this jack. It's fine for installations where there's not going to be a lot of motion or pulling on the cable out here, because once these tips bite into the wire, they create weak points here and here in the copper, because they actually bite down into the copper. So what happens when you use one of these connectors in an installation where this cable is going to be wiggling around and moved or tugged on like a mic cable, eventually that works this loose a little bit here, and it begins to put tension on the wires down here and pull on them. And those weak points where those pins have bit into the copper will eventually break. If this one over here breaks, it's not that big of a deal. You've still got this one back here. But if this one back here breaks, then what happens is the copper pulls back in that direction, this copper wire, and you lose connection. So RJ45 jacks, although convenient, are the worst connector to use in a microphone cable. Now, some manufacturers will dope this end up. They'll fill it full of epoxy or something and then put heat shrink tubing over the whole end, and that'll reduce the amount of play and the amount of pulling, and you'll get better life out of them. But in general, these connectors are just a poor choice for microphone cables, in my opinion. Okay, so obviously this one is bad. It's pulled back from the strain relief, the wires have been pulled on, and one or more of the wires have broken where those blades cut in. So what I need to do is replace this connector. And I have one right here. And I've got a crimp tool, so I've got everything I need to replace this connector. Now the wires, they're color-coded, so all I need to do really is I need to look at this other end here and map out which colors are where, and then I can cut this and re-strip it, or re-strip the insulation and get it set up to put on the new connector, and then I'll show you that process when I get to that point. So let me prep the end, and then I'll turn the camera back on. Boy, this is a real pain getting this right. You got to get those wires in the right order, get them all trimmed to exactly the same length, figure the insulation length so that when the wires are up at the end, the crimp will catch the insulation. And Icom made this even more difficult because this let's see, black, blue, white, and then this, what looks like a tan wire, is actually a shield that you have to twist up real tight so it'll fit in one of those slots. It's not a wire with a jacket on it, so that's I'm holding this real tight because it took me a while to get these wires to line up. Now I'm going to put them in the connector, and you get them in there and you try to make sure that they stay in order. Then you double check before you really push it in. Black, blue, white, shield, green, yellow, brown, red. Okay, that's the right order. So I'm going to shove these in there. You got to look and you got to make sure that all the wires reach the end of the connector. They're all butt up against the end. A little pressure here. All right, black, blue, white, shield. Oh, yellow and green switched places. Oh, man. There we go. I think I got it. Green, yellow, brown, red. Whoo! Double check. Black, blue, white, shield, green, yellow, brown, red. All right, shove this in. The wires are all the way up to the end. My insulation is well past the crimp. That looks right. Now we put the crimp tool out, and this is the way this works. You basically shove the connector in all the way. You hold pressure with the wire, make sure that the wires are at the end of the connector, and it clicks when it crimps. And we are on. You can see that the crimp has come down, pressed into the insulation to hold things in place. Black, blue, white, shield, green, yellow, brown, red. Got the wires in the right order, and we should be good. All I need to do is plug it into the radio, and we'll see if it'll transmit. And still no transmit. Connector on this end might be bad. Okay, I went ahead and replaced the connector on both ends. The connector on the other end was also bad. So, two new RJ45s, and now it goes into transmit. And we're getting power. 1, 2, 1, 2, 1, 2. But that's how you replace those RJ45 ends, which is really what this video was about. And I hope you found that helpful. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.